I'm Ellen. I'm on the programming team here at WECode, and it is a profound privilege and a distinct honor for me to welcome our final keynote speaker of this year's conference for today's exploration of the cosmos, Professor Lori Leshin. A world-renowned geochemist and planetary scientist, Lori has dedicated her distinguished career to the most fundamental questions of human existence. Where did we come from? What is our ultimate destiny? And are we truly alone in this universe? Her journey through the upper echelons of science and academia is a testament to the power of curiosity paired with visionary leadership. From her tenure as the Bren Professor of Geochemistry and Planetary Science at Caltech to her transformative 8-year presidency at WPI, Lori has consistently demonstrated a unique ability to unleash organizations, empowering them to achieve their greatest possible impact. Most recently, she served as the director of NASA's Jet Propulsion Laboratory, where she oversaw the pioneering missions that define our current era of space exploration and push the boundaries of our celestial neighborhood. Today, Lori joins us to paint a vivid picture of the dynamic future of space science. She will share not only her personal journey as a scientist and leader, but also her perspective on how our search for life beyond Earth reshapes our understanding of our own place among the stars. Whether you are a student of the sciences, a dreamer looking toward the horizon, or a leader seeking to inspire, her insights offer a masterclass in reaching for the impossible. So without further ado, please join me in giving an exceptionally warm welcome to Professor Lori Leshin.
Very nice, well done. Thank you, Ellen, that was so nice. And thank all of you for resisting the urge to stay in bed and watch hockey. It was hard to walk away from the game. I watched the first few minutes. Go Team USA. It's great to be here. Oh my goodness. My husband tells me stories of taking classes in this exact room. So I have not attended Harvard, but he did. And this building was the center of a lot of his work. He's an astronomer, and he's a space astronomer, and I'm a space geologist. So our house is pretty freaking nerdy. And I'm gonna take you on a little bit of that nerd journey with me today. I'm super inspired to be with you and to be able to speak to this group of rising women in the tech world, and here to support you and help you in any way that I can. And so what I'm hoping to do today, as Ellen already told you, is sort of two things. One, I'll talk a little bit about my own journey, and with apologies for talking about myself, which feels weird, but you'll see the embarrassing pictures go with it, so it's sort of funny. And then sort of transition and talk about what the questions that has inspired me since I was younger than you, to understand our place in the universe. And a little bit more about kind of where our space program is headed, and we can always talk more about that in the Q&A if you wish. So we'll come back to my girl Percy there later. But starting with me. So I often get asked the question, like, how did you become who you are? And, so it's really the question is, how to go from this bad hair day, middle school, junior high picture, very embarrassing, to being the president of a university and running NASA's largest federal lab and a truly inspiring place for science. So first of all, any WPI students here? No? Any WPIers at your conference? Ah, darn. All right, next year I'm gonna bug them about it. That was my inauguration at WPI, and that was my first day as director of JPL. This picture, my brothers tortured me with for years. I curl my hair so nice, and I was trying to look so good, and I didn't even know by the time I had the picture taken, one side was like, oh, and that shirt is really special too. But instead of torturing me with this picture, I decided to embrace it as part of my nerd journey. And there were lots of stops along the way to go from this. A young girl born here actually, but grew up in Arizona, to having these couple of really incredible leadership opportunities. And so there was kind of a lot in the middle there, including I was on a fairly traditional academic scientist path, straight through PhD and on to faculty position. And this was my students and postdocs in the lab that I ran as a young faculty member, tenure and teaching and all that stuff. As early in my science career, I had the opportunity to go to Antarctica to collect meteorites. We do that every single year. We go down to Antarctica and actually drive around and look for black rocks on white ice, which I'm a lab person, so that's about as much as I can do in the field. I can find a black rock on white ice. And having grown up in Arizona, that was the first time in my life I ever shoveled snow. You local Massachusetts and upper East Coasters will appreciate that was the first time in my life I ever shoveled snow. After about 7 years as a young faculty member and achieving tenure and all of that, I actually ditched my tenure and went and joined the government and moved across the country, moved to Washington, D.C. to work for NASA with my husband, who I had just married. He also came to work for NASA. He ended up running the astrophysics portfolio for NASA, so that was pretty cool. That's him, the Harvard grad there. And this is us in mission control in Houston during the last servicing mission for the Hubble Space Telescope, when they installed an instrument that he had helped build, and so that's the instrument that's between us there in mission control as we're watching the astronauts take it out and install it and test it and make sure it worked. Pretty exciting. So I was working in the science program at NASA, but then in my last couple of years I switched over and was working in the human spaceflight program. And so I had the opportunity to, so you all know, and I'll talk more about this later, we're about to launch a very important mission from NASA, Artemis 2. The capsule that sits on top of that really giant rocket is called Orion. This was the very first Orion capsule that was being built at the time that I was helping to oversee the future human spaceflight program at NASA. I got to do cool things like be on panels with Buzz Aldrin, and that's Charlie Duke, who was the command module pilot for Apollo 16. It was pretty fun, hang out with Neil Armstrong, stuff like that. It was pretty heady stuff. But really missed academia, really missed working with students, really missed opportunity to shape the trajectory of the lives of young people, and so went back into academia, and that's when I ultimately became president of WPI and then got called back to JPL to come back to NASA. But so it's been a varied journey is the point of this, that I've been sort of in and out of academia and government and federal labs, and so different kinds of organizations, and I'll tell you a little bit more about that lesson and where I learned it. So if I step back from all of this journey and ask, kind of what were some of the important lessons that I take away, how do I reflect on the path that I have taken? First, for me, I am very aware that from a very young age, I was inspired by really big questions, and I'm sure some of you are too. For me, it started at age 10, standing in my mother's kitchen, looking at this exact picture, actually. This is Time magazine from the mid-'70s, right after we landed on Mars for the very first time with the Viking landers, way before any of you were born, before probably most of your parents were born. I was absolutely riveted by that weird red picture of the surface of Mars, and I wanted to reach out and touch those rocks. I think it was because I lived in Phoenix and it looked kind of familiar. Mars sort of looks like the desert. Okay, you're gonna have to laugh with me a little more. I know it's early, work with me. Okay, so it kind of looked like home, and I was really excited I was just riveted. And I remember thinking, how did we do that? How are we able to get something to the surface of another planet? And is there anything crawling around out there? What's happening? And then as I was going through college, learning about the universe, and then as the Hubble telescope started to fly, things like the Hubble Deep Field Image, which you see there on the lower left, where you're seeing thousands of galaxies, each with hundreds of billions of stars, on a little piece of the sky that's as big as the eye of a needle. It's a teeny tiny piece of the sky, and yet within that teeny tiny piece of the sky are literally thousands of galaxies, each with hundreds of billions of stars. I couldn't even imagine just mathematically that we could be the only ones out there. And so this idea that not only might we not be alone, but just to understand how solar systems form, how planets form, and that's a very natural part of how stars form. And therefore, we're not something that's separate from, apart from the universe. We're very much a part of it. And that's very motivating for me. And then have been very lucky to work on the team for Perseverance's big sister, Curiosity, the rover that has been on Mars since 2012. I've worked on it from the very, very beginning. And again, it's trying to answer those big questions. The next piece for me is about mentors, but even beyond mentors, advocates. So I've been very fortunate in my career to have found incredible people who not only lit the way, not only flashed a flashlight and was like, yeah, that's where you go, but they actually either kicked down a door or they grabbed me by the hand and they showed me, right? That's the difference between a mentor who lights the way and an advocate who helps push you forward. And I've been very lucky to have some of those people in my life. The small image of the woman there, her name was Sue Wyckoff. She was an astronomer at Arizona State, where I was an undergraduate, actually. And I had seen an advertisement for a summer internship at NASA. I was 19 years old, and I was like completely riveted. Since I was 10, I was fascinated with space. Honestly, never occurred to me you could have a job working in the space program. I wasn't studying it. I was studying chemistry. I was just kind of doing my thing. But I saw this thing for a summer internship at NASA, and so I cold called her. She was probably the only female full professor in the physical sciences at ASU back then, in the dark ages. And I cold called her. I walked to her office. I knocked on the door. And I said, you don't know me, but there's this internship, but I don't understand any of these potential areas of research. I don't understand any of it. Can you help me? And I'll never forget, I can still see in my mind, she physically dropped what she was holding and said, sure, come in, have a seat. And we chatted, and she was explaining some bunch of stuff to me, and she kept saying, gosh, I wish I knew somebody there. I'd just give them a call. And finally she's like, well, let's just call them. And so she picked up the phone and called the number and said, oh, who's in charge of the intern program? Oh, I know Jim. Let me talk to Jim. Turns out she didn't realize this guy was there. And oh, Jim, how's your lovely wife? I have this fabulous student sitting here who she'd literally known for 20 minutes at this point. I mean, look, I had good grades. I studied hard. I did well in school. So it wasn't a stretch, but she didn't really know me. But that's what an advocate does, right? It doesn't just explain to you what it is. They pick up the phone and they call. And long story not at all short, I got the summer internship at NASA at age 19, and it changed my life. And back then, internships were not as common as they are now, but it was incredibly life-changing to go to Houston for the summer and understand what research is. And I got to work on data from that same Viking mission to Mars that had so fascinated me as a 10-year-old. And that was it. I was hooked. That was the lightning bolt. And it was because an advocate went the extra step. And it doesn't have to be a full professor who does that for you, right? And it doesn't have to be an older person who does that. You all can do that too. And so it's just something I really like to emphasize. And then the other is, who knows who this is? Anybody? Oh, please tell me you know. Come on, shout it out. Sally Ride? Yes, thank you. That's Sally Ride with a shorter hair than she often had in pictures. She's America's first woman in space. And I was extremely inspired by her when I was in school, and I'm very lucky to say that we became friends later in both of our lives. She passed away about 10 years ago from cancer, so we miss her terribly. But the best advice I've ever gotten came from her. I wrote it on the board out there. It is, break all the rules, but stay on the team. And I love that advice. And I kind of live by it, because especially as women in male-dominated fields, we have to break the rules a bit, right? We have to push the boundaries, is the way I think of it. So you push the boundaries, but you don't push the boundaries so far that you find yourself outside looking in, right? And that's a hard balance, and some days it makes me mad that I have to hold and carry that balance, right, as opposed to just doing my thing. But it's also a way to change systems. It's a way to push on making things better. So break all the rules, but stay on the team. And so great mentors and advocates. But probably the most important thing that I did as a relatively young scientist, and I guess the NASA internship falls into this, but even more so when I was a young professional, was I took the time to really be thoughtful about where I said yes. I said yes to a lot of things, but take opportunities that broaden your experience. And the most important one of those for me was this one. This is the President's Commission on the Future of U.S. Space Exploration. That's Vice President Dick Cheney. Rest in peace. And that's Neil deGrasse Tyson right there for friends and who are fans. So there were 9 of us that got asked to do this presidential commission. It was after we lost the Columbia orbiter, the space shuttle, 23 years ago. And it was, NASA was going to retire the space shuttle and move to what was next. And so they put a national commission together to look at that. There were 9 of us. I was the youngest of the 9, and the reason I got to do this is that I had met the head of NASA about 6 weeks earlier, and he was asking questions because he knew this change was coming. And he was like, well, what do you think? And I was like, well, everyone thinks we should redo Apollo. I don't remember Apollo. I don't, I'm too young. I don't remember Apollo. And I just remember him slapping the table oh my God, she doesn't even remember. That's hilarious. All I hear all day is we should redo Apollo. She doesn't even remember it. And so I was lucky I made an impression, I guess. But the thing about this that was incredible, one, the experience was amazing, but it was really the other commissioners. There were several of them. This guy who was the chairman, this guy whose name is Michael Jackson, not the singer. Michael Jackson had been the Deputy Secretary of Transportation on 9/11, and they basically locked him in a room for 4 months, and he created the Transportation Security Administration after 9/11. And then he had left the government, so at this time he was working in the private sector, but he'd worked at universities, he'd worked for nonprofits, he'd worked in government, he'd worked in the private sector, and he wasn't a space person, but he had this ability to come in and just sort of see the playing field and make recommendations that were palatable, politically, but also impactful. And it just made me realize, wow, except for 10 weeks I worked at NASA when I was 19, I have been in academia my whole life. I've only worked in the academic field. And a couple of them were like, Lori, you should go work in government for a while. You should think about this. And it was because seeing the breadth of capabilities that people brought to the table there, that 6 months later is when I ditched my tenure and went and joined the government. And so the idea that you're going to do, and I think now this is very uncommon that you would have the idea that you would do one thing for most of your career or even be in one sector. Really be open to different kinds of work. And this happened to me with missions too. This is how I got involved with space missions. I was a lab person, but one day my phone rang and it was a guy from JPL with a crazy idea for a Mars mission. And he said, is this crazy? I said, maybe, but why don't I fly out there next week and talk to you about it? And it ended up being a huge part of my career, leading a big mission team, my first big leadership role. And so you just never know when that kind of left field thing is going to come your way, organize a humongous conference at Harvard University. Takes a different set of skills than maybe you're using in your day-to-day existence, right? And so take those opportunities. Be careful, don't say yes to everything. I know it's super tempting. So that's the key, right? You got to start to cultivate some judgment about, hey, this is going to be interesting. I'm going to learn something new. It's going to stretch me personally in some way. And it's with people who are likely to make it a great experience. The other thing I should put on here, and then I'm going to start talking about space stuff, but the very one of the things that really drives me are the idea of magic teams. Teams that when they work together, I mean, teams almost always can do more than individuals can, so teams are a really important part of what we do. I hope that all of you will get to have this experience if you haven't yet, and you're a little young to have had it yet, but where you are part of a team where it feels like you can do anything. Like there's just magic that happens when different expertise and different backgrounds come together to try and solve a really interesting and hard problem. And this first happened to me when I was leading this mission team I was just talking about. And every morning I would wake up and think of, I thought of 6 reasons it wouldn't work. And I would talk to the engineers at JPL. I was still a professor at this point. And I would say, oh, but I thought of this thing and it won't work. And they were like, oh, no, that's an engineering problem. Give us a couple of days, we'll be back. And they would go, okay, we adjusted this thing, we fixed this thing, and now that's not an issue. Okay, but good, I thought of 3 more things it's not gonna work. Oh, no, we can go work that. And when you just start to see a team of different expertise come together to just solve anything, and you get to where you kind of know, you can look at each other and know, like, oh yeah, you go work on that one, I'm gonna go work on this one. It is magical, and there's nothing to me that's more special than a magic team. So those are some reflections, and I feel super, super fortunate, and every time I have the opportunity to talk about it, it just makes me feel so happy that these things are possible. And there wasn't, it was a combination of luck and opportunity and work, but it wasn't particularly unique or crazy, so it can happen to anybody. And because of all these various things that I've done, I'm super grateful that I get to be involved in trying to answer this question. I was involved as a scientist. I was fascinated as a young person. I was involved as a scientist, and now as a leader, I can help to drive some of the larger scale approaches to asking this question. And I talk about this now, answering this question, are we alone? We're kind of in a space race with ourselves about where are we going to find the answer. So I'm going to talk about 3 different things that we're doing to search for answers. All 3 of them are pretty heavily embedded at JPL. So this is a really motivating question for a lot of the work that we did at JPL. So one is exoplanets, planets around other stars. Just by a sheer numbers game, that's more likely that we'll find evidence of life elsewhere on an exoplanet, right? So we'll talk a little bit about that. Icy moons, the places where today we might have actual liquid water oceans. So we're exploring those, talk some about that. And then lastly, I say my personal favorite, but Mars, or just the planet next door. Wouldn't it be something if we discovered that life got started on literally the planet next door? What would that tell us about the possibility that the universe is really teeming with life? So we'll talk about each of these 3 just briefly. So starting with exoplanets. So exoplanets are planets orbiting other stars. When I was sitting where you are, we didn't know of any. We thought they should exist, but we couldn't detect them. We couldn't measure them. And now, as you see, this is now 18 months maybe old. We now have about 6,000 known exoplanets in the universe, and of course we're just scratching the surface. Many of these, almost all of these, were discovered indirectly, not by seeing a planet, but by seeing the effect of a planet on a star. Either the gravity of the planet shoves the star around a little bit and we can watch that wobble of the star, or the planet passes in front of the star and blocks a little bit of the light of the star. And we can measure that. That's what, you see that big pattern up there, that's from the Kepler mission, which we built at JPL, which stared at this one piece of sky for years and years and years and just watched the brightness of all the stars in that field and would see them get a little bit, 1 or 2% less bright. And this was again a year ago. We're already up over 6,000 exoplanets discovered, but again, all sensed indirectly. If we want to answer this question about life, we need to study those planets. We need photons from those planets directly. And so to do that is really hard. We're doing it a little bit with the James Webb Space Telescope, but our next space telescope is going to take a giant leap here. So our next space telescope, which is going to launch this fall, is called the Nancy Grace Roman Space Telescope, named for a woman, yay. Nancy Grace Roman was the first director of astrophysics at NASA, and she was really, really a pioneering woman in space. So the space telescope is going to look at dark energy and dark matter, which is super cool, but it also has a technology demonstrator on board to help us start to image exoplanets, to take family portraits of other solar systems. This turns out to be extremely hard because blocking the light, because planets, an Earth-like planet is 10 billion times fainter than its star. It's like trying to photograph a firefly next to a searchlight from 1,000 miles away. It's really, really hard problem. And so, well, you think, well, let's just block the light of that star, and then you can see the planet. That's exactly what we're going to do with this coronagraph instrument. This thing is about the size of a grand piano. Like, it's huge. This just little starlight blocker, and it's gigantic. And it's because light's a pain. It doesn't like to be blocked very, very effectively. To block it to 1 part in 10 billion is really, really one of the biggest technological challenges we're working toward in space. And this thing won't quite do it. It's probably 2 to 3 orders of magnitude worse than that. So it won't be able to see Earth's, but it's going to be able to see Jupiter's and Saturn's and Uranus and Neptune's around other stars. And not just see their impact on the star, but see them, see the light from those planets. So this is going to be truly incredible. It's full of lenses and deformable mirrors with thousands of teeny tiny actuators to help fully block that light from the star so you can see the planet. Let's see what else. Oh, here's the actual one. So that was the picture. This is the reality. This telescope is coming together right now at Goddard Space Flight Center in Maryland. They built the telescope. We built this coronagraph instrument. You see how big it is there compared to the people. This was the day they were actually putting it into the telescope. There it is, in the telescope. The telescope is now fully built out and just went through all its testing and is getting ready to ship down to Florida to get ready for a launch this fall. So be watching for the Nancy Grace Roman Space Telescope. It's going to be super exciting. So exoplanets, so we're there. So look, and again, this is going to get us Uranus's and Neptune's, right? We still need Earth's. We want to see Earth's. That's another technological leap. So the next big telescope after this will be something called the Habitable Worlds Observatory. It is still probably 15 years away, unfortunately, but it's really hard to do that. But it is our goal. Our goal is to image Earth-like planets with that telescope. And this is such an important pathfinder for that. Moons, let's come back into our solar system and talk about icy moons. We launched a mission while I was at JPL. We sort of built it and launched it. That is now on its way to Europa, an icy moon of Jupiter. So Jupiter has many, many moons, 4 big ones. One of them, Europa, is, and you see it here, is a shell of ice, and we believe it has a global ocean underneath with about 2 Earth oceans worth of liquid water in it. Can you believe that? On a moon of an outer planet. And the reason it's got liquid water is that it's constantly getting squeezed by Jupiter's gravity, and so the ice, because it's quite cold out there, 5 times further from the sun than the Earth, it's getting squeezed by Jupiter's gravity just enough to cause some of that ice to melt, and perhaps some of the rock beneath the ice to also interact with that, which would be a very interesting environment. Because if you want to find life, the 3 things we think you need liquid water to do the chemistry. You need the building blocks, the carbons and nitrogens that make up the materials of life. And then you need food. We have In-N-Out Burger. They have whatever. They can eat rocks. They can live off the energy coming out of volcanic environments, just like at the bottom of the oceans on Earth. But they need food, right? It needs an energy source. And so we don't know whether life is started on Europa or whether it has these ingredients, and if you mix them together in the right way, does life emerge? But it's probably our best shot within the solar system to find life today, to find current life, extant life, living things today. So, and we know very, very little about this moon, so we're going to go investigate it with a mission called Europa Clipper, which we launched back in October of 2024, a couple of days after a hurricane literally went right over our launch pad. It was like crazy. But so Europa Clipper, we built in-house at JPL while I was there, and it was an incredible adventure to watch this enormous, like school bus size mission, and it's solar powered, so 5 times farther from the sun than the Earth, still solar powered out at Jupiter. So those solar arrays are the length of about a basketball court, biggest solar arrays we've ever flown. And it's on its way. It's actually going to fly by the Earth for a gravity assist, because we don't have a big enough rocket right now to send it straight out there. So it did a Mars gravity assist. Now it's coming back around. It'll fly by the Earth this December, and then it gets out to Jupiter, and it doesn't get there till 2030. This is the thing about exploring space. You have to be patient. Space is big. It takes a long time for us to get anywhere. So this is Europa Clipper. I'll just tell you a little bit more about what it's going to do. So these are those 4 big moons I was telling you about, Jupiter at the center there. It would be great to just go into orbit around the moon and just like map the heck out of that. But the radiation environment at Jupiter is so hellacious that every time you get close to Europa, it's like getting 100,000 chest x-rays. Like, it's nasty. And so the way they've designed the mission is to fly in close and just fly by, and then get out of Dodge for a while and get out of the radiation environment so that the spacecraft lasts longer. So we're going to do about 50 close flybys during the prime mission, and probably even more after that in an extended mission. And by doing that, we'll get to sort of map out that whole moon, trying to understand the things like the thickness of the ice. Are there places where the ice gets thin? Because we can see on the surface that occasionally water must sort of erupt out. And so are there places where the ice is thin? If we later wanted to send, a submarine, where would you send that? We want to understand what the chemical makeup is of the surface and the interior if possible, and a bit about the geology on the surface as well. And so we've got 10 different science investigations. So you building the spacecraft is one thing, and then we've got all these different specialized sensors, every wavelength you want to look at. We've got things that if there are geysers on Europa, we'll fly through them and taste the geyser, to see what it's made of. It's just going to be a truly comprehensive and incredible view of this ocean world. It's an ocean world just like ours. Not just like. It's an ocean world like ours, more like ours than most anything else in the solar system. So it's going to be really epic, as the slide says, once we get out there in 2030. So be watching for that. And just to show you can see totally artist conception, of course. But what we really want to understand is the crust and then what's beneath that. And doing things like, amazingly enough, measuring the magnetic field as we fly by can teach us about how salty the ocean is and how it's circulating, and we can get a sense from the chemicals on the surface of what might be going on underneath. And again, if there are these geysers, that's going to be exciting, and there's a lot of debate about if there are geysers or not. So it's going to be fascinating to see once we get out there. We think that ice is a few tens of kilometers thick in most places, but probably in some places it gets quite thin. And we'll have ice penetrating radar and things like that that are going to allow us to kind of see into the ice. So that's going to be amazing. I doubt we'll see whale bones on the surface or anything, so it won't be something quite so obvious, but we might well really get a sense of if there are building blocks of life there, and we'll see. And then finally, Mars, the planet in many ways we've explored the most. And JPL has led, of the 11 times we've landed successfully, humanity, on Mars, or is it 9 times? All but one were led by JPL. The other one led by China, had successfully landed a rover that looked a lot like our rover. couple years ago. Didn't last as long as ours, interesting. But we today have 2 car-sized rovers driving around on Mars, including one that we just celebrated the 5-year, what we call Landiversary, the Landiversary of Perseverance. Now, before I talk about the missions, though, I just want to give you like a little bit of context. So on Earth, and life on Earth drives some of how we look for life elsewhere. That's the one example we have. On Earth, life started extremely early, it turns out. Like pretty much as soon as it could emerge on Earth, it did. Now, our rock record of that time, over 4 billion years ago, around 4 billion years ago, is terrible because of plate tectonics and erosion, and like we just don't have a ton of old rocks on Earth. So it's really hard to explore the ancient life record on Earth. People have done it, it's controversial, but they've looked hard at all the oldest rocks. Any place on this planet that has really, really old rocks has been very well explored just to try and understand the emergence of life and what Earth's environment was like back then. But it's really hard to do. There's like a little bit in Australia and there's some in Canada, and it's just hard. Mars, on the other hand, over 50% of its surface are these ancient rocks. It has a slightly less intense geology, I would say. And so the older rocks in many places are preserved. So in some ways, Mars is a better place to go look for the emergence of life than Earth. And so it's a fascinating place to go explore. And so Perseverance, and we have this abundant evidence that unlike today, when Mars looks like the dry desert of Arizona, and it's even drier and more deserty, at this time, early in solar system history, almost 4 billion years ago, it was warm and wet. There was water everywhere. We have lots of evidence of dried up lake beds and dried up river channels and even maybe oceans, some shoreline evidence. And so let's go explore some of those ancient, well-preserved water environments on Mars and look for ancient life. And that's what we're doing with Perseverance. So I call her a girl. I mean, she's smart and good looking, so I think she is a girl. That's just me. I probably shouldn't say that. That's probably bad. Anyway, I'll say it in here. This is where she went and is, although she's driven up kind of out of the crater now. So this is the rim of a big crater called Jezero. And you see this thing coming in and this thing right here? That's a dried up riverbed and a big river delta. Just spilled into this big lake that used to be inside this crater. And so we landed about over here. We drove up to the edge of this river delta, then we drove up on it. And now we've kind of driven up to the mouth of the river, and we're actually out of the crater now in the ancient plains of Mars, which are also really interesting for this question. But here she is on the surface, and the goal of Perseverance is to get into the rocks because that's where the evidence of ancient life will be found. And so she can drill. So you see a couple of holes here where she drilled into a rock, and she can take selfies because obviously she has a camera on the end of her arm, just like when you take a selfie, but hers are like a bunch of little pictures that they put together down here on the ground. But they're pretty good, and it's so cool just to get to see her spacecraft there on the surface. So we'll look a little bit at how she does this. So that's the arm, and it's got a drill on it, and you see her drilling in. And then she takes these rock cores, each one about the size of your pinky, and puts them in, seals them in individual tubes, and she's storing them basically in her belly. Underneath the rover is like a city of robotic activity that goes on to store these rock cores, because to really answer this question about ancient life, we know we've got to get the right rocks back in labs on Earth where we can tear them apart atom by atom, labs like the one I used to run when I was a young professor, where we can understand at a microscopic level what's going on chemically and structurally inside these rocks. And so we have been doing that on Mars. We've been running around and collecting rocks, and they're very interesting, and it's a mix of igneous rocks, of volcanic type rocks, and also lots of sediments because it's a lake bed. And I just want to stop on this one, Cheviot Falls, that we discovered sort of accidentally. One of my more interesting days as director of JPL was the day that I got an email from the chief scientist of Perseverance, the rover, saying, I think we might have discovered life on Mars. Well, could you call me? Maybe not do it by email? Like, could we talk about this? And it was because we found this rock. And this rock is, this vein here is only about 1 centimeter across. It's not very big. So you can see we can take nice kind of close-up pictures here. But you can see these sort of things they called leopard spots, the light-colored spots with the dark-colored rims. That is a very interesting structure. And again, remember I said we need water, we need organic materials, and we need energy source if we want to think about biology. The red stuff here are clays formed by water. And clearly water was flowing through this rock some billions of years ago. Energy can be in the form of an oxidation reduction reaction. Bugs love that, they can eat that. And the dark rims around the light-colored interior are where they've taken the red, which is oxidized iron, and reduced it and precipitated out some of the dark rims here. So that's oxidation reduction. And we have a way to sense organic matter, not in a ton of detail. We can't find like strands of DNA or whatever, but we can see if there's organic material. And we haven't seen that much. The very surface of Mars, it's pretty oxidizing, not that good. This thing popped for organic material, chock full of it. And so, and if you had seen a structure like this on Earth, like that dark rim with the light interior in a sedimentary rock like this, you would say it's probably a biosignature. Something is causing that oxidation reduction to happen, and it might well be preserved in this rock. So we call it a potential biosignature, because it might be one, it might not. It might be some regular inorganic process, but it's a really fascinating rock of just the right kind. Exactly why we came here is to try and find the right thing. If you just land anywhere and scoop up some stuff and bring it back, you're not going to find something like this. You've got to explore the region thoroughly and be a little bit lucky and find something like this. So the cool thing is we drilled into this thing and we bagged it. So this is the end of the rock core, and you can even see the little leopard spots there. Can you see them? Yeah. So we bagged it. It's literally sitting in the belly of this rover right now, waiting to come back to Earth. Now, anyone who follows the NASA budget, and I really hope and pray that you don't spend very much time trying to do that because you'd be depressed right now, knows that we're actually not doing this mission right now. So this was a big mission we were pushing to really get going while I was at JPL. It is not currently in the budget to actually fly a rocket to Mars, get the samples out of Perseverance's belly into the top of this rocket and launch it. We've never done this. We've never done the round trip at Mars. We have landed there 9 times or something, and we're pretty good at that. Coming back is a whole other challenge. You have to sort of launch a little volleyball-sized capsule up into orbit, and then you need to send a big orbiter to go grab it and bring it back to Earth. Not easy, and by the way, if you think sending humans is easy, it's much, much harder even than that, and we haven't even done this. So we have a ways to go, but I am going to continue to argue for and advocate that that is the best shot we've got in the near term to find evidence of life on another world. It is sitting in the belly of a NASA rover right now. We need to bring it home. So if anyone ever asks you, what do you think about Mars sample return? You say, bring them home, let's go. Bring them back. So all big missions, all large complex missions, James Webb Space Telescope, Hubble, Europa Clipper, they all have what I call near-death experiences. They all get they're great, oh, they're canceled, oh, they come back. So I'm hopeful that we will get this thing back on track. And part of the reason we will is because the world of space is changing, and it's a really exciting moment. And as I wrap up, I just want to make a couple of comments about that. So I'm sure that all of you are aware of that it feels like some things are shifting in space, and it's an incredibly exciting time. And science needs to be a part of that change. And so that's something I'm working on a lot in my new role at ASU, is sort of how science needs to change and evolve given the changing landscape of what's available to us. So, and again, we can talk more about this in the Q&A maybe if you all want to, but great success last year, Firefly, first fully commercial mission, landed successfully on the surface of the moon. This is after a couple of other ones didn't, several actually, including International. These guys are amazing. They did their testing at JPL, actually. They're a great, great group of folks. The next big lunar lander is literally, this was taken last week, I think. This is Chamber A at Johnson Space Center, which is one of the largest thermal vacuum chambers where we can test like in the space environment, simulate the space environment on Earth. And so this is Blue Origin, Jeff Bezos' space company. If you're a billionaire, you have to have a space company now. It's like, I don't know, it's the rule. I mean, even now, Eric Schmidt has one, and Elon and Bezos, anyway, and Branson, they've all got them. So when you become a billionaire, so just write that on your resume now after you have to start your own space company, because I'd really like a woman to start one who's a billionaire. That would be nice. So they've got their big, this is a robotic lunar lander. It's much bigger than this one. This one is this big. This thing is a beast. And they're testing it right now at Johnson Space Center. Hope to launch it later this year to the moon. That will really open up a new era of lunar exploration because they can deliver a lot of big stuff to the moon, big infrastructure, which is what we need to go back to the moon and stay. And then there are other commercial companies like VAST who are thinking about the end of life of the International Space Station. You know, we've had humans continuously in space for over 25 years on the ISS. The ISS useful life is coming to an end around the end of this decade. And we want commercial companies to have the next stations in space so that we can have more commercial research. I mean, biotech can go crazy in zero G. The kinds of things you can grow in the space station, crystals that that you can't do here on Earth. It's just truly incredible. And you know, we should start universities up there. I think it'd be awesome. So this is a concept, not yet flying, but there are several private companies that are close to starting to launch elements of private space stations. That's also good for space tourism. And then, of course, there's our friend Elon with Starship, which is, you know, so the thing about SpaceX is, and I was involved in the early support of commercial launch programs at NASA that really were part of SpaceX's early funding that allowed them to succeed. They have done incredible at bringing down launch costs by something like a factor of 10, 5 to 10, I would say, in the last decade. Starship will take that to the next level, assuming they can get it working. It's really, really hard what they're trying to do. It would never put anything technical past Elon, but it often takes longer than he promises. You may have noticed that. And so we'll see once Starship gets flying. But, you know, as of in 2025, there was a launch approximately once every 28 hours globally. Almost one a day globally. That's extraordinary. And that is up from like 34 hours the year before. So the pace is increasing really quickly. And we have about 5,000 satellites in orbit right now. Most of them are Starlinks, but about 5,000 satellites. That number was 2,000 in 2020. And it's probably going to be 10,000 in the next 10 years, and increasing more rapidly after that. So it is just a whole new era of space commerce and space commercialization that presents huge opportunities for science to tag along and leverage the incredible infrastructure that's going to be built. And the moon is a big focus of that for us, people who care about NASA and care about NASA science. So this is, well, it's 3 of the 4 Artemis II crew members. These 2 are backup crew members. That's Reed Wiseman. He's the commander of Artemis II. They visited JPL last year, and so that's with a bunch of us JPLers. They are fantastic people. He's an RPI grad. Any RPI people in the audience? No? Okay, yeah. So he's a great guy, and this is the crew that, well, they went back into quarantine because they thought they were going to be able to launch this baby. This is Artemis II stack that was out at the pad, that are with an Orion capsule on top, which is what these 4 folks will ride in. Liquid fueled. It's a lot like the space shuttle stack, actually. A liquid fueled core with solid rockets on either side. They just yesterday announced that they've decided they need to roll it back into the giant vehicle assembly building at Kennedy Space Center because they're having an issue with the upper stage. which is going to push this launch out. Instead of being in March, it's going to be probably end of April. We'll see. But they'll launch when they're ready. And this is important. It's historic. I want you all to pay attention to it. It's the first time since the end of Apollo that humans will have gone beyond low Earth orbit. Think about it. Space shuttle just going round and around the Earth, round and around, ISS, round and around, round and around. These folks are actually going to go deeper into space than any humans ever have because of the way their orbit takes them. They go further beyond the moon than the Apollo program did. First woman ever to leave low Earth orbit, Christina Koch. Awesome. She's amazing. Love her. So it's an exciting moment. And it's the next step in kind of returning to the moon to stay, in returning to the moon to kind of expand Earth's economic sphere, to expand our way of life to other worlds. And ultimately, that's what we want, to be out among the stars. It's a hard problem, but it's one worth doing because we have big questions and we want the answers. And I know they're out there. So anyway, thank you very much. Oh boy. It went too long, sorry.
Thank you so much, Lori. Can we please have another huge round of applause? And now we have some time for questions. So if you have a question, just raise your hand and we'll...
She jumped right up there.
Yeah, okay. Yeah, go ahead.
Hi.
Okay, hi. So I've seen some research about finding life and studying the formation of life in volcanic lakes on Earth.
Yeah.
Do you think that we can use these places on Earth to unlock knowledge about life elsewhere, or do you think we're going to have to look outside?
No, I think we absolutely have to do both. I think that's a great point. So like kind of different environments on Earth that have interesting life, extremophiles and other things are super important to study. And in fact, a lot of our strategy comes from things like when we discovered the black smokers at the bottom of the ocean, and there was all this, they were just teeming with life in an environment with no sunlight. We never ever would, harsh chemicals, we never expected there to be life there, and there it was. And so absolutely studying the extremes of life on Earth, extreme cold, going to Antarctica and working in the dry valleys, understanding that, absolutely. They do it up on the space station. They want to understand how life responds to radiation, right? There's just a lot of different environments we need to understand because space is has very diverse environments. So yeah, absolutely, very important. Sorry, are you calling on people? Okay, go ahead.
So how do you find the creativity to take yourself out of the biased perspective of Earth to solve problems inside of environments that don't exactly have the same conditions as Earth or might not even have the same explanations as Earth does to our problems?
Yeah, I mean, I think there is a sort of a bias, and a terrestrial bias, if you will, that happens for sure. On the other hand, hydrogen, most abundant element in the universe, and water, oxygen, also very abundant. So water is really it's in a lot of places and it's important. Long chain carbon molecules, I get asked a lot about, could we have other, like silicon-based life and other things, and people do debate it. But carbon loves forming these long chain complex molecules, right? And so there are just a lot of things about how, we sort of use the most available stuff to us. And so it sort of seems smart to start at least with kind of life as close to what we know. But we're also able, again, if you bring samples back to Earth, we can throw everything at it from an analytical perspective. And that means you don't have to have a super bias about what you're gonna find. And I do think it's important that we think as broadly as we can. I mean, to the point where some people think about life in the upper atmosphere of Venus, because the surface of Venus is 3 times hotter than your oven and nasty with, acid and that. But maybe up high, or maybe even up high in the clouds of Jupiter, there are people thinking about super creative stuff. And as we learn more about exoplanets and their diversity of, how they show up, I think it's going to continue to just have to expand our thinking, and which is so exciting. Yeah. Okay, yes, and then we'll kind of go up. Yeah.
So I'm so impressed
Oh, thank you.
And particularly because, you had a hobby from an interest, and now you managed to do that. I mean, we can't wish anything more for anybody in this
Exactly.
room
Yeah.
that your hobby, your passion supports you in this way, and you still have another 20, 30 years to do this
I'm pretty
wonderful-
tired. I don't know.
to have this huge impact
Thank you.
on this question. So, but the thing I may disagree with you a little, but I want you to
Yeah.
say more. Is you made it look like, okay, you had mentors, you had advocates, you had some luck where the guy called up somebody
Yeah.
and got you an internship at
Yeah.
NASA. But luck doesn't happen like that, in my
Yeah.
opinion. So I want to understand from you. You probably had 15 other things like that happen where somebody made a phone call or didn't.
Yeah.
But you must have had something going.
Yeah.
Curiosity, was it
I call it 20 seconds of courage.
what was it?
Yeah. So it's a little bit of all it, like, again, cold calling the woman professor, I was scared to death. Like, I was like, oh, I don't know if I can do this. And then I call it like the 20 seconds of courage, right? Like, just all it takes is like 20 seconds to walk down the hall and knock on the door, and then you're in, like, and either they'll say yes or they won't. But, and then I think you can also get smart about who are the people inclined to help. Most faculty know that the best part of their job is helping change the trajectory of a student's life. That's why they do it. It's not for the money, that's for sure. Like, they do it because they know they have a lifelong impact on people like you. And so they almost always want to help. They might be busy, this might not be the right moment, right? And you should know going in, like, hey, and if now isn't a good time to talk, I'd be happy to come back when it is. Or, I got lucky she dropped what she was doing. She might have said, I'm too busy right now, I'm running to a class, can you come back later? So it's not getting discouraged when the answer isn't yes right away. And just, so some persistence and some courage. Yeah, oh my gosh. Let's go all the way to the back and then we'll come back down. Yeah.
How do you think we can get more women into the space tech industry, and how do you think we can foster environments that are more welcoming to maybe who just haven't seen others like themselves?
Yeah. So look, it's a hard moment for that, and I'm super psyched that you all are having your conference. There have been great fellowships, like the Brooke Owens Fellowship is for women to do internships in the commercial space business, and they almost all get hired. It's incredible, but right now with some of the federal environment going on, those things are harder, but they will come back. And so, like, just a little bit of patience and finding folks who are still willing to help is important. So I think it's getting early experiences. I think exposing people to just the positive intensity of it. Like, I've seen, men crying in mission control when it was looking like something was going really wrong, not with the humans, but with their instrument. Like, if people think that science is like the passionless pursuit of knowledge, like we in our white coats, whatever, it's not, and nothing could be further from the truth. It's the passionate pursuit of knowledge, right? It's all about, and so exposing more people to that and having people understand that the team environment can be really special. And then we need to keep making sure that we're listening to every voice and that we're inclusive in how we go about our work, because that's how the best things emerge. That is an ongoing journey, one that starts here in college, where you learn how to work in teams effectively. Hopefully, you're getting some coaching on that, not just figuring it out on your own, but all those things are really important. And then for me, that's one reason I give talks like this, is just to show what's possible. So thanks for the question. Yeah, okay.
I have multiple questions.
Uh-oh.
The first one maybe is, there's so many sectors that try to foster as much, creating an international environment for people coming from different countries.
Yeah.
But then the space sector is one of those where they tend to be really national.
Yeah.
There's European Space Agency,
Yeah.
Space Agency, NASA, et cetera, et cetera. And collaborating
Yeah,
with
global.
like creating
So she's asking about, in case you can't hear in the back, about the kind of globalization of space, but there still feel like there's silos by country. And at some level that is true, but I also think that more than ever there is an acknowledgement that we're not going to set up a moon base alone. We're not going to do that on our own. We're definitely not getting to Mars on our own. The Mars Sample Return mission was a collaboration. Almost every single science mission we do is a collaboration between space agencies. There are now 60 signatories of the Artemis Accords, which the US started, but they had 10 more signatories just last year. So, which are basically kind of rules of the road and ways of operating for lunar exploration. And so I think there's really increasing recognition, but unfortunately, so much of what we do is about how money flows. By the way, this is good advice on any topic. Understanding how money flows is often really important. And money flows through governments. Although the commercial space sector rising will also shift that, because investment can come from lots of places, and a lot of companies are very multinational. So as we shift to a more commercial model, we will continue to see, I think, more multinational approaches. So it's a bit of a both and. There's definitely still going to see the national pride piece, but the collaboration is super essential. Yeah, do we have?
Can I just add on to that? You mentioned a lot also these commercialization and creating these kind of commercial space agencies.
Yeah.
But there's also a bit of worry around that because first of all, there's not really legalization in space for what is for each person.
Yeah.
There's no borders kind of for which country.
Right, so we need a good policy framework for the commercialization. Yeah.
Around
Space traffic management,
So
yeah.
what are the next steps that are being taken?
Yeah, there's a lot of push to rethink a lot of our policy framework is pretty antiquated. It came from 50 years ago. The Outer Space Treaty and other policy frameworks didn't really envision a commercial space sector in the way that we have it now. They also didn't necessarily envision long-term residence on other planets. And so there's a lot to do. It's not quite happening fast enough in my view, but in some ways the technology is going to push the policy. And so we definitely need to do that. I may take a couple more. Can I keep going or do we have to stop?
Maybe, sorry, just one more. Is
One
that
more,
okay?
I'm so sorry. Yes, okay.
Hi, my name is Anya. Nice to meet you. It's so nice hearing about your journey. I wanted to know a little bit more about what you studied through each phase.
Yeah.
Up to like your PhD and postdoc to kind of support your journey.
Yeah, so I started as a chemistry major, mostly because I had a freaking awesome freshman chem professor, and I was like, this is cool, let's do this. And so I really was not super driven as an undergraduate. I had been fascinated by space as a kid. I was studying chemistry, and it was really that summer internship at NASA that allowed me to focus, to say, oh, okay, if I want to do this, which I do, I now see I need to go to grad school, I need to do, and so then I started on that path. I did undergraduate research. I was very lucky when I came back to ASU after my summer internship to do my last 2 years. I decided I wasn't going to, everybody else who does planetary science is a geologist, and I was a chemist. And I was like, oh, should I switch my major? I've never taken any geology, like I don't know anything. And I decided, like, I'm not going to stay an extra year, I'm going to stay in chemistry. But ASU was one of the few places back again in the ancient times that had actually jointly appointed chemistry and geology professors. So they were doing interdisciplinary very, very early across chemistry and geology, which is unusual still. And so I was able to sort of cross that boundary myself. And then in grad school, I switched fields. I switched into a geology department, and my PhD's in geochemistry. And so that was sort of then the path from there. And then I was a professor of geology. And so switching fields, hard at any time in your career, but super valuable because it means you think a bit differently than everybody else in that field. So don't be afraid of it. I'm sorry that I talked too long, and I'll stick around for a few minutes and answer more questions if folks want. Thank you.
Yes, thank you so much for all the wonderful questions, and let's have another round of applause for Lori.
Thank you.
So yes, we do have our next speaking slot at 10:45, which will feature a panel and a few solo events. So if you have more questions for Lori, let's please maybe bring it outside so that we can set up for the next event. But yes, thank you so much for your engagement, everyone, and we'll see you in the next events.
All right. Was it good? Was it okay?
Joined by three extraordinary leaders who are proving that technology is at its best when it serves as a deliberate catalyst for equity, sustainability, and human wellness. First, please welcome Rati Thanawala, a distinguished leader in the tech industry and a dedicated advocate for the next generation of innovators. With a career defined by her leadership at Bell Labs and her focus on the 19 levers for long-term career success, Rati specializes in helping professionals navigate the transition from academia to industry. Her work emphasizes that thriving in tech requires more than just technical skill. It requires a strategic, human-centric approach to leadership and social impact. Next, we have Bonnie Titone, Executive Vice President and Chief Administrative Officer at Duke Energy. With a 30-year career spanning leadership roles at Volkswagen, Toyota, and PG&E, Bonnie now spearheads the digital transformation of one of the nation's largest utilities. From AI-driven grid resiliency to cybersecurity, she is at the helm of a historic energy transition grounded in community needs. Finally, please welcome Lucina Tse, COO and co-president of Demagi. Operating at the intersection of engineering and operations, Lucina leads a social benefit corporation dedicated to empowering frontline workers worldwide. From agriculture to maternal care, her focus on impact delivery ensures that technology provides real, measurable solutions for the world's most underserved populations. So please join me in giving a very warm welcome to our panelists, Rati Thanawala, Bonnie Titone, and Lucina Tse. So we're going to start with some speaker-specific questions. So first for Rati. Tell us a little bit about how your journey towards working in tech for social good has gone, and is this something that you've always wanted to pursue, or did your career begin somewhere else?
Well, that's a very good question, and it's very different from these two ladies who will tell you really what it's all about, social good. So for me, you know, I came to this country from India when I was 20 years old, first generation immigrant, no family here, nothing. I did my PhD in computer science. And then I started working at Bell Labs. It was a R&D part of AT&T. And I worked there for 39 years, and I did lots of different things. The last thing on my mind was social good. I mean, that was not, I was raised to, you know, do what you do best. I was very good at math, very good at science, and so I was going to apply myself, and I did. And I rose very fast up in that company, got promoted to vice president, and then I was vice president for 16, 17 years. So social good I didn't do. What I did in terms of social good was mentor a lot of students because I was rising so fast. I always had a perspective that others didn't. So whether it was a bunch of Asian students who got together, say, let's have her as a speaker, or whether it was people wanting to hear about performance review, and I knew more about performance review, how it's done in companies than anybody was willing to open up and tell, you know, the employees. So I did all these things, which were like social good, but it was local social good. And of course, I worked on commercial technologies. That's what Bell Labs is about. We won 9 Nobel Prizes. It's a very big R&D place in those days. So we invented technology that helped people. But I wasn't inside of me working to do something to nurture, you know, this whole thing about social good. I was just a first generation immigrant. I need to get married, I need to have my kids, I need to buy a house. I don't know anything in this country, and I'm going to spend my effort doing that. But then I transitioned at some time, you know, like 7 to 10 years ago, I started thinking, why am I here? What's my legacy? If I stay at Bell Labs, am I going to invent the next new technology? Probably not. I need to start my encore career. And I need to do something in the social impact space. Just raising 2 beautiful daughters, very smart, who might do things in the future, that's nothing. What's expected of me? How much has been invested in me? All these clothes, somebody stitched these somewhere in some village somewhere, you know, the intellectual things that I got from generations of people who've gone before me. All of these fancy privileges, and then all I'm doing is 2 kids and this and that. I was like, this is not it. I still have 20 years that I could give back. And I don't want to just retire, travel, do a little mentoring, little this. I want to have huge impact. And what can that be? And so I came to Harvard. I retired. I came to Harvard because they have a special program that teaches people in 1 year of
for a second career, like an encore career, who want to do social impact. But these are people who worked in different industries, and they come, and they already have the leadership skills. But now they are asked to find that thing that really fires you up, and within 1 year, you get to that. So I came to the conclusion that I will teach young people how to succeed in tech careers and teach them while they're in college. So when they transition to the workplace, they're going to go like this. They're not going to go like this, okay? And I thought it could be taught, and we proved it. So I wrote to Melinda Gates, and I said, Melinda Gates, I want to do this. She was not Melinda French Gates at that time. And so I said, this is what I want to do, because it's the non-tech skills that make the difference. The tech skills get you hired. It's the non-tech skills that get you promoted. Nobody ever told me I'm promoting this person to manager because their tech skills are great or not great. It's all the rest of it. But none of that is taught except internships and co-ops, and they're not sufficient for the depth you need. So I came to this conclusion. I wrote to her. She said, here's a grant. Go do your research. And then she gave me more money, and others gave me money to actually set up a leadership academy, a research project to make sure that you can teach these things. And a year or two later, are people ahead of a control group. So we did that, it's finished, and now we are commercializing, making this into, like a thing where every university, we want them to teach these programs and their foundational set of courses. And then, so one more piece, and then you can reduce my time for the other questions. The goal is not just to teach the women and minorities to succeed in tech or to have higher impact. It's also to teach the management to change the culture so that it's more fair for people who are different from the norm, whatever that is. Whether it's flexible work hours, whether it's any kind of policies, need to make sure that those are changing. But that system takes longer to change, and the individual is faster to change. So I said I need to do both. So I'm working on the Leadership Academy things for the students, and like at conferences like this. And then I'm working on the management stuff by telling them how they can change policies and how they can partner with these young people whom I'm training to be change agents of the norms in the workplace. They're going to change the norms. Believe it or not, it's just not the policy and the top people that change it. It's the people going in if they are trained. And so that combination then will make a faster thing. So I have, 2 years ahead of me, 5 years, 15 years, who knows how much time I have. But whatever I have, that's what I want to achieve as social good. But it started very late in terms of these women who might have started right from the start. So,
Thank you. That's a really refreshing perspective to hear how you started somewhere else, but then got into the social impact space. So now a question for Bonnie. So Duke Energy's generation strategy signifies one of the most significant transformations within the utility industry. Could you elaborate on why this transition is essential for the communities the company serves, and in what ways do you anticipate that AI-driven technologies will enhance resiliency and facilitate Duke Energy's energy transition and broader social impact over the coming decade?
Yeah, I thought maybe I just would start with who Duke is. We're one of the largest utilities in the United States. We do everything from generate power to transmit it to distribute it. So fully regulated, meaning we don't have any commercial business. Everything we do is overseen by the government. And we have about 55.
Sorry.
Is it on us? Is it on us? How about now?
Yeah, you
I'll
can
just
put
hold
it closer.
We have about 55 gigawatts. So you're probably like, what's 55 gigawatts? An average home uses 1,000 kilowatts, which is the smallest denomination, in a year, right? So we have 6 nuclear reactors. We're the largest, 11 nuclear reactors across 6 nuclear plants. We're the largest nuclear operator in the country. And the interesting thing that we're seeing now is utilities and power are really what is driving dominance across countries. It used to be, you just needed energy to turn on your lights. Now you need energy to drive what AI dominance is going to be in the future. Without energy, you can't power a data center. Without the data center being powered, you can't drive this whole AI transformation that we're seeing. So For the first time in over 2+ decades, we are seeing this massive amount of growth that you just really haven't heard or seen about in the utility industry for a very long time. And when you couple that with wanting to drive the vitality of the communities we serve and the customers that we serve, we feel this sense of obligation in order to deliver reliable and resilient and safe power to not only our communities, but we feed the Eastern Interchange. So in other words, like if our power utility doesn't, if our lines don't feed energy, it would take down most of the eastern side of the country. So that's we feel a very sense of importance of the work that we do. Right now, if you can read any headline out there, if you pull up the Wall Street Journal, the New York Times, whatever it is, there's this dialogue around utilities being slow and not moving at the right pace and stodgy, so to speak. That we're a 100-plus-year-old company. But the reality of it is, if you look under the covers, we are really moving more towards being a digital tech company than a utility, right? If you look internal to what we're doing, everything on our grid and everything in our back-end systems is all tech-enabled and digital-enabled, which is a great place to be. And we feel a sense of obligation in order to continue to find ways to deliver that resilient power to the communities we serve, and do so in a way that drives the engagements of the community around us. So it's a fun time to be in utility. We, in the next 5 years, will spend $103 billion with a B, $103 billion on grid modernization, which includes a ton of the technology that allows us to have power continue to run through our lines, two-way power. Traditionally, a power grid's been one way. We give you the power. But think about EVs and solar and battery and all these things that are putting energy back onto the utility grid. It now needs to communicate two ways. That with our infrastructure and building 12 gigawatts of power generation over the next couple of years is really an interesting time to be in the utility. And we feel a sense of obligation in order to deliver that in a way that our customers see value behind it.
Wow, that's incredible magnitude of what Duke Energy is doing. So now moving on to Lucina, can you tell us a little bit about the work that Dimagi does? And from my understanding, it spans a really wide range of sectors, from agriculture to maternal care to healthcare. So which is the most meaningful to you and why?
I'm happy to. So maybe a little bit of background on Dimagi as well. Dimagi is a company which really focuses on the social impact and creating digital services and tools for frontline workers. And whether that means in rural Africa, where there's not a lot of healthcare systems, enabling frontline workers to work directly with pregnant women and deliver services to them. That's a part of what we do. We do a lot in agriculture as well for the farmers and data collection to help them improve their crop yield. And so the technology we build is ComCare, and it allows you to do that data collection. But a lot of what we do isn't just about the technology. It's about how we're partnering with the people on the ground to deliver those services. The technology is just a part of it. And we want to make sure that the technology really enables the work of those on the ground, because it's not going to take over what they do. The work that we're doing, it enables the offline collection, because there's still places in the world where you don't have access to internet and things like that. We've worked with women who've had to carry these huge ledgers going around from village to village, and they have to not check off, I visited this household, I've talked to this person about their pregnancy and whatnot, and what we're trying to enable is an easier workflow for them. So that's a lot of what Dimagi focuses on, and what we want to make sure we're enabling is the sustainability of that impact. Sometimes it's not always going to be true. We want to be able to deliver the technology, and after the program is done, the program is done. But we've also had cases where it really matters, and they've really appreciated the tool that we've been able to give them, because it really enhances the work they're doing in reducing child mortality rates, infant mortality rates, and other things like that. And so that's a big part of what our focus is. And your question on what's the most meaningful to me, I joined Dimagi more because I was interested in what technology could do for social impact, not specifically on one sector. The one that I guess I've worked the most on myself with the company has been in nutrition.
And so we've had cases in which we've worked across states in India to deploy for the frontline workers of like, hey, how do you monitor child nutrition and malnutrition, and ways that you can enable people to teach and learn about that and deliver that. So for my career at Demog, maybe I've spent more time on that aspect of it, but like, I think the thing that I'm most excited about is the ability for it to impact so many different sectors.
Yeah, that's really great that you're focusing on something, but there's also a lot of possibility in other areas as well. So now going back to Rati, what advice would you give to an aspiring technologist who is also passionate about social impact, and how would you suggest that they blend the two of those?
Well, that's a very, very good question, because so many people that we teach, people like you in the room who are technology, doing computer science, engineering, majoring, they come to me and they say, I'm torn. Because on the one hand, I'm very good at math, computing, engineering, and I love it. But it's very dry. The role models, the 90% of the people in that field, you know, they just are there all night doing coding. It doesn't look like the same brown pants they were wearing for a whole week, you know. I am not that kind of person. I am interested in 5 different things, and I also want to do social good. I am interested in, say, poverty. I grew up very poor, and now whatever career I do, I want it to impact and improve the poverty of that area I want to have impact on. And I'm not sure if I do my master's or even bachelor's, whatever I'm doing, how am I going to use it for that purpose? Should I be doing sociology instead? Because that is where people who want to do things on poverty go take sociology. They don't take computer science. So they're torn between their purpose, feeling like it should be sociology, let's say, as an example, but their skill set and interest and doing very good is also in engineering and computing. So they're torn. So should I major in sociology and take a minor in computer science? And so they'll make some time to talk to me. So the problem is, the solution is, the answer is both. The answer is both. So what I tell them is, number one, do you know Esther Duflo? But who is Esther Duflo? Esther Duflo, 6 years ago, won the Nobel Prize for economics. She was at MIT, the youngest woman, 45 years old, and she won the Nobel Prize with her husband and another person. What was it about? It was at the intersection of poverty and tech. So prior to their work, people did field experiments in sociology to reduce poverty and similar things. And they would have, in one village, 20 people or 100 people, they'd run an experiment and show that that solution is working by giving them little loans or whatever it was. They never did large-scale experiments like we do in engineering with building bridges and things. You know, we never do a 20-person experiment. But that's how sociology was. Completely changed over because she brought the tech and sociology together, and now you have to do thousands of things, experiments, and gather data, and that's how you see why is it that children in schools, even very poor children, but you give them schools, but they don't get the education. Why is that? We're putting the best schools there, but they're not getting education. How are you going to solve that? You take hundreds of data points, thousands, and you do. So they revolutionized the way this is done. They set up a lab at MIT. It's called the Poverty Lab. They did all this, and they transformed the whole thing. That's why they got the Nobel Prize. So I tell this girl, this woman who's in front of me, you're very unique. You're one of the probably 1% of the people in this world who are interested in both. Do not make a choice. I can talk to you for your bachelor's degree, do the tech. And for your master's degree, then later, go do the sociology. I'll tell you which order is better. I'll help you figure it out. But do not choose, because you're in a unique position. And you're only competing with those few thousand people in the world who have both interests. So you're unique. Don't be like, I'm one of the few bad ones because I'm interested in both and I don't know which one to do. That's a problem. Here, you're in a place of strength. So I say tech, you guys are very special. You guys are very unique. There are 11 sectors in the United States, like energy, like others, and technology is one of them. Technology intersects every sector. There is not that much overlap between, sector A and sector B, but technology intersects every sector. So no matter what your other interest, it could be space, it could be anything, you will find an intersection. And then you just go for that intersection. And you develop your interest, your curiosity, your field, do that. And you'll be very successful because the number of people competing with you are very small. So I just think that this is the sector to be in, and you can do social good. You can do lots of different things with your interests if you're in the tech sector.
Thank you. That was incredibly encouraging. So now back to Bonnie. How does Duke Energy collaborate with local communities, governments, or startups to ensure that technology solutions are grounded in real community needs?
Yeah, I think for us is we see it has to be a connection with public and private. In other words, we can't do it ourselves. There's certain things that the utility is going to bring to the table, but you need the other pieces of it. And so we've always taken this view of it's where can we find the right partnerships to deliver something that we're trying to bring, whether it's to our communities, whether it's to bring to the company, the customers, whatever that looks like. And we've done that we've cast a net pretty wide. So, some examples of it are, we have a long-standing partnership with Jules Accelerator. Think of them as a nonprofit that goes and partners with startup companies, but in the manner that they bring the startup companies to the utilities and say, what are the things that you need? What's the problems you're trying to solve? And then we work together to bring something that not just will benefit Duke, but is going to benefit the whole utility industry. And that could be anything from grid resilience to technology that manages solar farms, to vegetation, to wildfire. I mean, you name it. It can come across our entire sector. And the interesting part about that is they get to partner with SMEs and smart people within the utility, but they're bringing the technical expertise that maybe we don't have, or in combination with what we have, and we end up bringing solutions to the market that solve a real world problem. And the partnership has been great for us over the couple of years because you get to build and deliver things that are really meaningful. And the interesting thing about utilities, I think some people recognize this, some may not. We don't really compete with each other. We have a right to serve. We have an obligation to serve where we're at. That's why we're heavily regulated as an industry. And when we solve a problem at Duke Energy, all ships rise. Right, we are helping all the other utilities across the country in also solving problems. So we love that about the fact that we don't have to just solve the thing for us. We're solving it for an entire industry, which is really fun because you don't get that in a lot of other industries. I come from automotive. I've spent a large portion of my career in automotive. You wouldn't share anything. Everything's secret, everything's your IP, but it's just not like that in the utility. There's things that are certainly that we build for Duke, and we want it for Duke, but most of it we can solve a community problem. That coupled with, we do partnerships with a lot of the local communities that we're in. We have a pretty big relationship with E2D, that stands for Eliminate the Digital Divide. It's everything from us giving tech skills to the communities in which we serve, helping people get access to technology that maybe don't have the means to do so. We give them a lot of our equipment instead of recycling it. We give the equipment out to these partnerships, and we're building the next generation and giving, like you spoke about, you have to give the people the opportunity, and we feel like just because the only thing that separates us is the opportunity to something. So that's one other thing. And then we spend a lot of time with the government, the local law enforcement, the FBI, doing things to try and drive safety across the utility industry. So this is everything about protecting critical infrastructure. We're doing some really amazing things with drones and satellite technology, so that we have the ability to see what's happening around critical infrastructure and getting in front of it as a reactive manner instead of a proactive manner instead of reactive. And we see that as protecting the communities in which we serve.
Nice. Okay, so now to Lucina. One of the key pillars to Demagi is its focus on impact delivery. So can you explain a little bit more about this, and how is it different from some of the other current approaches to social good?
When we're talking about impact delivery, the thing we're talking about is really enhancing the services we're delivering. So again, it's not just about the tech that we're putting in the hands of people. It's not just the data collection. To collect all that data, what are we going to do with it to improve the services of those that we're helping? And so the focus is on what are the workflows that make it easier for a frontline worker to be talking to someone? What are the tools that we can give them that in those moments will help them do their job better? And so one of the examples of this is a program we have called Connect, in which we're not just looking at having the tool in front of someone. We have training platforms on the phones that they can use to help them really increase their skill and ability to deliver those services. After we have the training programs, then there's Verify. You can take tests to do certificates and things like that, and then do the service delivery to improve the outcomes that we're talking about. So when we're talking about the impact delivery, it's about, again, that sustainability aspect, and that we're providing the tool. The tool is just one part of it. We're not there just to do the data collection. We're there to help create and enhance workflows such that it really increases the impact of what we're doing, whether that's in maternal and child health or in other areas. For example, in agriculture, if you're just looking at the dashboards themselves, that might not be helpful, but developing the tools to help you really understand what that means. That's we're going further than the basics of what might be required for impact delivery.
That's great.
Thank you. So now we're going to move on to some questions that I'll pose to anyone who would like to answer. So from my understanding, all of you guys may have started in different careers. You mentioned automotive, and Lucina, I know you used to work with superconductors, and Rati, you talked a little bit about it. So what made you go from your previous career to now working in social impact?
Okay. Do you want to start?
Yeah, sure.
I had a very traditional engineering path to start with. So my background's in electrical engineering, and then I worked in the semiconductor space. And I had a very similar moment of oh, what am I doing? I had a moment, so I was doing that for maybe 5 years in semiconductors, and I remember it was 11 p.m. at night. I was coming back from working with Apple in California, and I was on a call with a Japanese client, and we were talking about, oh, this isn't working well enough, and I'm supporting them, and we're just doing this product launch. And then I thought, what am I doing? What am I doing? Is this actually exciting for me? It's I'm spending a lot of hours, I'm doing great work, and this is something the company appreciates, that the clients appreciate, but is this right for me? And so when that happened, I didn't immediately jump into social impact. I went to do an MBA, which was also very different. But my reason for that is I'm very, I need a baseline net person. And so I wanted to make sure as I was doing my career shift, I would learn more about the business side of things. And also I chose to go to Oxford, which had a school in social impact. So I wanted to learn more, to give myself the tools and the skill set. And then coming upon Demagi was we were talking about this last night, is that intersection of tech and social good that was very, very exciting for me in the potential that it could do. And so it's not an easy world to work in the space that we're in, to be honest. The global health space has changed a lot in the last year alone, for example. And so it's not exciting every day, but at the end of the day, when I'm thinking about it, I'm oh no, what the work I'm doing is enable someone else to deliver better services to help malnutrition children somewhere else in the world. And that gets me going to continue to make sure that we're going to deliver the best we can in whatever role that we have.
Yeah. I mean, for me, I worked 16 years, I mentioned, in automotive. Prior to that, I worked at a startup internet company. Prior to that, I worked at a software company, so I was doing product development and implementation of software. And it was very similar. I think you get to a point in your career where the work's the work, and yeah, you get satisfaction in delivering something and seeing outcomes. But when you really start to think about what is the footprint that I'm going to leave? What is the thing I can look back on and say, hey, I really made a difference, or I impacted something in a positive way. That was the shift for me after 16 years of working for two of the largest automotives in the world, which was awesome, and I learned a ton, and it put so many tools in my toolbox that I still use to this day. I really wanted to go work somewhere where you can drive what the next generation is going to look like for a company, and the utility space was that for me. I saw myself with an opportunity to drive digital transformation within a 100-plus-year-old set of companies that really felt that if they didn't find a way to use the technology and really disrupt themselves, somebody else was going to disrupt them. And I wanted to be part of that not being somebody else. I wanted that to be part of the internal engine that ultimately has driven a lot of change that you're seeing across the utility industry. So it was for me that I came from a tech background. My whole career had been in technology. And how did I put that against a mission or something that was bigger than myself? And that's, powering the communities in which we serve and our customers. And every day I get up and deliver something to a set of customers that without the product that we deliver, they can't function. I mean, think about what it's like when you lose power. Does it disrupt your day? You can't even go minutes anymore. When I was growing up, you could light a candle and maybe you could make it a couple hours. I mean, those days are gone. Everything we do needs electricity, and I wanted it to be part of delivering what that could look like in the future. Yeah.
Okay, so another question is, this is a big conversation nowadays, but given the rise of AI and automation, how can we ensure that technologies will enhance social equity rather than increase it?
Let me start with that. I think there's a lot of hype with AI in terms of the focus that I want to do is what we all need to learn in order to be successful in the age of AI. AI is going to do lots of things, and it is doing them. It's automating things. But in terms of the young people getting to the workplace, what do you need to know that you wouldn't have needed to know if you were, in 2 years ago or 3 years ago? What is expected? So I am very focused on how do we have people getting in there that can have impact right away from get-go in a company like any of ours in the age of AI. Because what's happened is one of the big impacts have been on entry-level jobs. Because first year or two used to be, way back then, was like straightforward kinds of things that people, it were execution things. And then you did that a little bit, and then the cream rose to the top, and then they got to be team leaders, and you got in the culture of the company in order to learn how things work. And you got in a year or 2 years to do it. Well, all that other stuff is being done by AI. So you don't get those 1 year to figure it out. Right from get-go, you have to be your judgment, your ability to ask for help, your ability to raise your hand and say, we shouldn't really be doing this. There is no reason. Last year you did it, but now we have AI tools, we have other things going on. We don't need to even do this. Are you able to make that statement? Or are you so shy and lack of confidence that you can't make that? You say, well, let me lay low for a couple of minutes. It's not. So in the age of AI, what should we be teaching young people to do? And how should managers be supporting the young people that are going to join their firm? Managers don't know. 90% of them are clueless. I'm sorry, you can quote me on it. But 90% of them got promoted within a few years. They haven't gone to all the management training. They love machines. They don't love people. They just, got promoted. Now, the people you see on the stage had both aspects. That's why they achieved what they did. But all the rest of them are clueless. I asked them, how do you support do you support women? Because even now, only 81 women get promoted for 100 men. Even today, in the industry. Even after 30 years of so much focus on women, okay? So what's going on? This broken run. This is awful. So I say, but as managers, how do you suppose women and men, and is there a difference? No, we are totally fair, we support them. How do you support them? Well, if a woman wants to see me, I give her time. If I give 30 minutes to everybody, I give 45 minutes to the woman. So they view that because time is a critical resource, they're going to give more time, and that's their way of support. I asked the women, what was the number one thing that your manager supported you on that is memorable for you? It's never about time. They remember the time when a problem was solved where they were not told, oh, the reason you didn't know about these jobs in the other organization is because you don't network, you should be networking more. That's nonsense, because it could be very difficult for that person to network. So they changed the rules. The manager changed the rules by saying every time a new project starts, we're going to have it on the website 24 hours before it started that says I'm hiring for a new project. So everybody finds out at the same time that new staffing is happening in a big company. Okay? So the thing is, that is what the woman remembers as support, not you should network more and you should do this and you should do this, and that's ridiculous. But managers are clueless. They're not biased necessarily. I mean, some may be, but 90% are just clueless. So it's the age of AI. There's going to be 10 times more of this going on, because very young people coming in new will be asked for their judgment and for their creativity and for their passion and their advocacy and their initiative, which is not something that was expected day one. Well, 1 or 2% or 10% of the people may have shown that and they get promoted, but 90% were not expected to show that at get-go. But now everybody is expected to show that. So for me, the impact of AI in my domain is the preparation of the young people as they get to the workplace and continuing to lead, where in the age of AI, there'll be lawsuits. There'll be lawsuits. There was a lawsuit at Airbnb, I think I told some of you, where people were, if they were black or they were this or they were that, they were not getting the reservations. It was a huge lawsuit, huge. People in the company knew about these things. Nobody raised an alarm. And last month, there was another lawsuit about some similar problem at Airbnb. So, the problem is people don't do what they're supposed to. Because algorithms are doing it. Algorithms are doing all this work, so people are not watching. And when they see it, they don't yell. They don't scream. They don't. They say, I'm not going to be. So for me, the age of AI is how do I succeed and how do I contribute in the age of AI? Do I take another AI course? You have to take the AI courses. That's a prerequisite, knowing the AI tools. But that's not sufficient. It's just necessary, but it's not sufficient.
Yeah, I think for us, first and foremost, when we went into, we've been doing AI since 2017, and we've been lucky enough at Duke to have a pretty large software engineering arm, which isn't traditional in a utility. And we've built 50 plus products that have driven $500 million of value to our company. But first and foremost for us was responsible. And we felt a responsibility to put the guideposts around how we're going to use it, what data we're going to give to it, who's going to oversee it, those type of things, so that when we got to the point where we put it in our tools or we handed it to our teammates, we already had the bumpers up for them, if that makes sense, so that they can feel comfortable working within the space that we're allowing them to work. And I think that's incredibly important over the course of time as it gets smarter, right? Because you have to have the ability to continue to validate what's going in at the information, and having the human really use their intelligence to drive the outcome of that. We will not get away from that piece of it. There is certainly going to be work that you won't have a human touch anymore, and that's okay, but those are going to be the low risk things. Everything else requires that we have humans and people looking at the information, looking at the models, continuing to make sure we're driving the bias out, continuing to make sure that we're using it in a responsible manner. I think that's the obligation we have, not only to our teammates, but the customers in the communities in which we serve.
Yeah, I think for us as well, it's that care. And again, our mission is to enhance workflows. So we've started testing in using chatbots and whatnot for frontline workers, for them, not to replace them.
Right.
And we've seen some cases where there's been success of it really enables them to get that information faster, to do their work faster. So we've seen faster visits, for for example, which allows them to spend the time and care to really talk to the individuals that need to do what they care about. And so it's about the care and being careful we're putting in the workflow. On the operations side, because like I also run HR, I think something Ratu was saying very carefully of like, it's changing. Like, if you learn about what AI is now, it's going to change next week. It's going to change like a month later. And so what we're expecting for new people that we're hiring is your ability to adapt and change.
Yeah.
It's no longer about like, hey, just about the skill set you have when we're interviewing you. What we're also going to be looking for is, can you use AI to learn?
Yeah.
Like, use it as a tool for yourself. Use it as a tool for yourself in terms of what are the problems you're able to solve now with AI that you couldn't solve before. We have a higher expectation now for individuals at the company to be able to learn and like do that for training and things like for themselves, because it enhances your skill set, right? It enhances your skill set and what the company is eventually able to do. Yes, we can talk about automation. Yes, we're going to talk about all the agents and everything like that. But it's really, really important and critical that you're going to continue to learn and change and adapt, because that landscape is changing so quickly.
Yeah, that's great.
Okay, thank you so much. Can we please have a round of applause for our panelists? Now we're going to open it up to questions. So if you have a question, just raise your hand and please specify whether it's speaker specific or if it's open to anyone.
Mine's just open to anyone. How did you guys lead, and like, what is your leadership position like, and how has it evolved throughout your career, and what makes you an efficient leader compared to other people, and what strategies do you use for your teams?
I mean, I can answer the last part of it. You know, you got to surround yourself with really smart people that are smarter than you, and listen to them, right? The best thing that I've learned over the course of my 30-plus year career now is that you as the leader need to create space for people to come in and help you tell them what the problem is, help them tell you how to solve it, and give them the opportunity to do that. I think a lot of times, specifically as a female, when you feel like you need to solve all the problems, have all the answers, be the first one out of the gate, and it's just really not true. You need to create space for people, smart people, to help you figure out where you need to go, what it should look like, and how to get there. And I've definitely given myself the opportunity to say, I'm not the smartest one. I'm gonna take that person's guidance and just create an avenue where they can just go get it done. And that's, smart people around you, I think, is really important.
Yeah, that resonates with me. Like, I've also learned, you don't have to be the smartest person in the room, but like a part of what I look at is being a multiplier. A part of why I wanted to get into leadership and move away from like the direct individual contributor is like amplifying impact of others, and that part is really exciting to me. My approach is much more of a coaching style, so a lot of when I'm chatting with my team and things like that, I ask a lot of questions. Because I believe that my team is very capable of like solving problems on their own. What they need is guidance on how to get there. Another thing I've really leaned into is I'm not the most aggressive speaker in the room. So when I'm on a management team with a lot of men, right, and they're going back and forth and back and forth, I'm much more of like the observer. But whenever I speak, I know very clearly what I want to do. I'm never shy about speaking, but I don't feel like I have to speak all the time. I feel like everything I want to say, I'll make an impact to. And that's like how I feel like I make a difference in the room when I'm with other leaders, and my approach to that. And that's something I had to get coaching on, because I was like, yeah, all these people around me, they're very alpha, they're very like, oh, I have a lot of these thoughts, and I'm very different from that. And what I've learned is like, it's okay, lean into what style is the best for you to enhance the workflows that you need to.
So I think Lucina said something very interesting, that every leader will have a different style. There's no one style of leadership, and there's no one way to lead. And the only thing common across all leaders is they have followers. There's nothing else common. I mean, so many people in the world who are leaders, but they're all very different. Some are loud, some are soft, some are team leaders. But the only thing common is people follow them. That's what makes them a leader, that they have followers. Okay, if you don't have followers, you are not a leader, right? So I go with that basic definition, and then I say, what is inside of me that's special, that's truly special, that nobody else has around me? And can I make that strength into a superpower? So they are going to select me for roles where that superpower is needed. Because in the end, in the beginning, you might get just promoted or given roles and responsibilities, but as it gets tougher, if you're going to select a basketball person for a basketball team, you'll select for that one thing that you're missing that you want. And then you go looking around for that one thing. You're not selected because you're an all-rounder. You're not selected because you have fewer areas for improvement. You're selected because you have that strength that's unique and like a superpower. So finding that superpower in myself in the early years was my daily quest. What is it? And then I found what it was is that I can work 2 times longer than anybody else because I had my mom for 30 years in my house, looking after my kids in addition to babysitters. And so I could put my foot on the pedal and it was 9 p.m. at night and I could be working. And those were the days when people thought you were on a mommy track if you had kids, and so you were nobody, okay? But for me, I had a wife at home, basically. And so I could be there at all times. I said, look, this is my superpower. When I say I can do something, I will get it done 100% of the time, okay? With the team, with people, but partly it's because I can work twice as many hours as anybody else over here. Nobody's waiting for me at dinner at home. I can be here all night. So this is bad today to say this, but I'm just saying I found what is my strength. Some of it was me and my brain and my own commitment to my excellence, and achievement is my top value. Higher than family, higher than justice, higher than anything, my number one value is achievement. I have to achieve, otherwise I'm not happy. So I know that about myself. Wrongly or rightly, that is my value. So I married the achievement with having my mom at home, which was wonderful, and all of this, and I said, I'm going to be the one that gets the job done. So whenever there was a tough job, let's ask Rati to do it. And then Rati did it, and even sometimes I didn't do it. But the answer was, it didn't work, but if someone else had had it, it wouldn't have worked even worse. So, the fact that she did this much is better. So every time I got the benefit of the doubt because it was aligned with how I operated. Anybody said, a difficult job, who wants to volunteer? My hand went up because I knew I could work extra hours. And I knew that I had it in me to I will never not deliver. So that became my thing. In the early years, it was trying to figure it out. What is that set of things that makes me a Superman or a Spider-Man or whatever? What is that? And once I had it figured out, I didn't waste time about, somebody said, you don't listen well. I said, forget it. I'm not going to spend time on listening skills. I took one course and said, forget it. It's not, if it's my weakness, I'll bring it in. Just do enough so it's not a weakness. But I'm not going to spend time working on 15 things. I'm taking my strength and going for it, And so I think every one of us has a different strategy to how we developed ourselves. But there must be a strategy. You can't just be doing like this. Somebody told me this. Well, people will tell you whatever they'll tell you because it's based on their values and their view of who you have to be. You know what you are like, and you know what flexibility you have. And you got to use that to have the highest possible impact in the workplace. And that's kind of how I do my mentoring for students also, is to help them find the nuggets. What is it? Where is their superpower? Help them with that. Thank you.
Thank you. Any other questions?
So my question is, although technology continues to grow and opportunities continuously keep arising for northern areas, would you take the risk of losing the momentum of your current progress to bring these to rural areas to improve the quality of life and bring quality, or would you rather stay up north to focus on increasing knowledge and unlock the potential of discovering the newest thing that could potentially help even more people than just rural areas, with your given resources and given the comfort of your known resources?
That seems like a you question.
You probably have the
I want
most.
to do it all. Just back to our thing. I mean, it depends on where we're most suited to solve the problem. Like, if I would be lying, like, yeah, I want to do everything, but like, if we're not the ones suited to solve the problem with those resources, it doesn't make sense for us to do it. Demagi's focus has been a lot of working in the rural areas because we believe that's the most underserved and where our technology makes the most difference. And at the same time, during COVID, we were able, because our platform is very malleable and you can use it for a lot of different resources, we were able to work within the US and serve populations within the US for contact tracing. Right, and so it really, you have to be able to understand where your product and where your technology fits the best to deploy the resources that matter most and then make that impact. Sometimes the trade-off might look like, oh, but if you stay within this population, you'll have like this bigger impact here, but nobody else can do it there, right? And so that's a lot of what Demagi focuses on is like, it might be a hard problem, but there's nobody else to solve it. Someone else might be able to come in and solve the problem for the areas where there are resources and there are people to do it. Like Salesforce did contact tracing and other places were like, great, you can take that because like that's what you do best. But for areas where it's underserved, that's what we focus on in the populations we do. Does that answer your question?
All right, any more?
Let me start because I know a person from Ghana and I can have her connect with you if you'd like. We discussed her story yesterday, Miriam from Ghana. So again, I have my filters, so I'll tell you my personal view, right? Don't take it to heart because this is for me. I think starting very early, getting into these domains where you have zero credibility, you haven't yet built your base, can be very hard. And so one way is that you develop yourself first and get to a point and work for a company that has a reason to be in Ghana. So for example, Miriam, who some of you were there yesterday, I showed some a video. Miriam is from Ghana. She wants to do things for Ghana, but she studied here, she studied at Harvard, she went to work for Netflix. Why? Because Netflix wanted at that time to expand into the Africa market. Her interest was not in entertainment for Ghanaians, no, but it was Ghana that she wants to serve. So she worked for Netflix, to some part of Netflix, and over time made her way to understand what is their plan for increasing the number of subscribers in Ghana and went to visit Ghana, and now she's coming from Netflix to visit Ghana. She has all the support, the teams around her. It's not on what she wants to do. She hasn't figured that out yet. After doing that for a few years, she now wants to do, because she's at Netflix, she's an expert on what do you call it? UX design. What do you interface design, user interface, UI design. Because at Netflix you have to do user interface. And there are hundreds and thousands of students in Ghana who don't have an opportunity to do anything and learn that technique. So she now started a new startup. And that startup is working with American firms who want to expand in Ghana and using that student base and educating them in Ghana and then saying those 20 students, I have got them figured out, they're going to come work for Microsoft and help Microsoft do user interface research in Ghana. So she's come full circle, all right? But the point is, if she had tried to do that as an undergrad, I'm not sure she could have done it. You have to hear her talk to tell her the difficulty. She went to Ghana, they said, you're American. She comes to America, they say, you're from Ghana. You know, it's like very difficult in an entrepreneurial world to be all things to all people. But having gotten that stature and herself figured out, then you go in with a place of, even then she may or may not succeed, but she has a much higher chance of doing something for Ghana now than she would have as an undergrad. So my feeling is, when you're starting to crawl, you can't take on something that big. You can, it might succeed. There are so many entrepreneurs that succeed right out of the box. But I think that's not a good strategy. That could happen, but it's not a good strategy. Just, it's a personal view, so don't take it to be more than what
I think
what
your
I
point
think.
is start with the smallest piece
Yeah.
that you can. Like, you don't need to solve the massive problem. Pick the one thing that can be the entry point in. It could be something small, right? And start with that. Like, what do they say? How do you eat an elephant? One bite at a time? It's like that. You put tools in your toolbox that you can tap into that will ultimately get you to the thing you want to solve. Yeah.
Yeah, experiment. Experiment with all these different areas, right? Like, there's lots of parts of a problem. What you started with might not be where you end up.
100%.
And so it's that skill set, tool belt that you want to be building to make sure you're enabling yourself of, like, why are you the unique person to be able to solve the problems that you want to solve right now, and building the skill set to enable yourself to adapt to all these different things, I think.
Yeah.
Thank you so much, you guys. I totally agree with you. You guys are music to my ears. I love listening to you guys. My question, something Raki said about, I think I'm on this similar path as you, where I shifted from India in 20, no family, nothing, and I'm also on path where I'm a little lost, intersecting multiple different disciplines that I can go into that can also combine with that. So my question is kind of, where do you find, how do you kind of strike the balance of intersections versus being spread too thin and feeling like I'm like a jack of all trades, master of none, versus actually like making like a valuable intersection between two industries?
You guys.
Yeah, I think it goes back to the discussion we were just having. At some point, you do need to pick something, because if you're kind of doing a small percentage of a lot of things, you'll end up having too many priorities, if that makes sense, and you need to pick a priority. And what I would tell you is, and this, I'll give you a little bit of my background. I'm a hotel, restaurant, and institutional management major. I've run technologies in large big brand companies most of my career. So what I would say is, pick the thing that feels the right thing, and maybe don't pick too many of those, and just do it, and then you can shift. Once you get into an industry, I started at a software company, and now I work for a utility, and I've been across 5 industries in 30 years. So my point to you is, just because you pick something doesn't mean you're stuck there. And I'm a use case for you're not stuck.
Whatever you pick, make sure you do it very well.
That's
Yes.
right. Amen.
Like, when I was in engineering, I was like, I'm going to make sure I'm the best AE that you have on the team. When I went into engineering management, I was the first engineering manager at Demogi, but I was like, I want to make sure I'm the best. Like, now I run operations. You shift from, like, all these different things, but it's because I made sure that I was the best at what I did in those areas, so that I gave myself more opportunity. Like, without proving yourself in some area, it's really hard to open yourself up to an opportunity that you've never tried. So there's so many different possibilities. Pick the thing that, like, you think you can shine in, and then I think you can keep jumping. It's not like all of our careers have changed so much over time, right? It's not, you're not going to pick one thing and do that for life. Maybe some people do, but that's not really a norm. And just make sure you do it well.
Companies want people who are curious and who can problem solve. Right. The subject matter expertise is just a bonus.
I just want to say one more thing, and we can talk afterwards if the time is short. I think at this age, when you're not like in the workplace, it's really difficult to figure this out yourself. But if you go to a mentor, anybody like us or anybody, and you start talking, because you mentioned the word confused. So when you talk to people and you're trying to explain what your confusion is or what you're looking, immediately people will ask you questions. When are you happiest? Are you happiest when you're coding? Are you happier when you're building something physical like a product? Are you happy when you're doing this? And they'll force you to answer and to get into domains that you haven't thought about. And you yourself, working with a person who's like a mentor, who's had more years like we have, will be able to help you crystallize. The reason I like this is because I'm good at it. The reason I like this is because it's a hobby. It's not the same. This one I enjoy doing, music I enjoy, but I'm no good at it. But I'm very good at jigsaw puzzles, but I don't really enjoy it. So it's like you find out what you're good at, what you love doing, and what you're great at, and you're great at music and you love music, but then I ask the question, will it meet your financial needs? You may have to sleep on some friend's couch for 30 years before your music career will blossom. Are you prepared to do that? No, I'm not prepared to do that. I need a proper job as soon as I get out. Okay, then think about music, you know? And so there's 4 circles. What you're good at, what you love to do. Does it meet your financial needs, your idea of how much money you want to make, of success, what it looks like? And the 4th circle is there a purpose or priority that you have? If you can find something at the intersection of those 4 circles, check, go do it. But if you've got 2 or 3, or you haven't figured out purpose and mission, a lot of people don't figure out when they're very young. Okay, but the other 3, are you great at it? Do you love doing it? And it'll meet your needs. You don't want to, in year 1 or 2, you know, you want a $100,000 job straight out of college, then you're constrained with what you can do. So look at the intersection of things, and you can't do it yourself. You need somebody like a mentor, somebody who's willing to spend time, and they'll ask you the simplest questions, and all of a sudden this stuff will start becoming clearer. So that's what I would say.
All right, we're unfortunately out of time, but the panelists will be available to talk and answer more questions if needed. So yeah, let's have another big round of applause for all of our panelists. Thank you so much everyone for coming. We will now be transitioning to lunch, so I believe that will be served outside in the Central Arcade. So yeah, enjoy the rest of the conference. Thank you.